everybody, for joining us, from me and from Ulf. Let's start with a quick introduction. Ulf, maybe you can kickstart and give a quick introduction about yourself, whoever does know you.
Okay. Thank you, Alon, for inviting me. Yeah, I'm very excited about talking about data, security, and where it's going. So my name is Ulf Mattsson, and I'm now at my own consulting company, ulfmattsson.com. So I was the CTO and founder of Proliferation, that is focusing on data security and privacy solutions. So I have about 20 years of experience in the field of data security, and I used to be at IBM 20 years. And I invented faultless tokenization at Proliferation, which is very exciting, I think, a new way of protecting data. At Proliferation, I worked on driving product innovation and strategy. I formed strategic partnerships and alliances. And I'm very glad to be here. And I have issued and awarded more than 70, well, I think 73 US patents. I have 2 books on data privacy and security. So if you're interested, you can actually read more about these topics in my books.
Thank you.
That's my promotion. Thank you.
Thank you. And my name is Rosenthal. I've been also doing data security for the last 18 years. I am the forefather of dynamic masking. I invented dynamic masking in my first company, which later was acquired by Informatica. And then I left Informatica 7 years ago, now it's even 8 years, to found Secupy. Also seeing the adoption of data security in different use cases, which we're going to touch today, were the main reasons for me to start and re-engaging after my first company again with data security was to solve the over-fragmentation of the market from 2 dimensions. First, the dimension of features. To this day, there are companies who are doing monitoring, right? Database activity monitoring. There are companies who are doing, of course, encryption and tokenization. There are companies who are doing attribute-based access control, ABAC. And there are companies who are doing masking, physical, dynamic masking, and deletion for production, non-production. And the first reason I founded Secupy was to solve that problem, to provide a single platform that will be able to address all the different colors of the rainbow from a data security perspective, from discovery classification, monitoring, dynamic masking, access control, ABAC, what we call the protection of data in use, and of course the protection of data at rest with encryption, tokenization, and all of that in one installation, one enforcer to solve them all. And the second reason I founded Secupy was in order to solve something that people who have been in data security for a long time understand: the lack of context, right? Who's the end user, right? You would look at database logs and you will scratch your head and say, who's the end user, right? You just see service accounts, or you would see just IPs, or you would see everything coming from right, a certain domain, right? Lack of context is hurting our ability to protect our data. Lack of context both on who's the end user, who's the identity of the user, but also what are the relevant attributes of the data. Is it sensitive or not? Is it PII, PCI, PHI, right? Is it a VIP client or not? Right? All of those challenges are still there. And this is the second reason I founded Secupy, to solve also the lack of context, which is eminent both for the monitoring of access to data, even access by business users that are using end-tier application, serverless technologies today, to poll data, or whomever of you who've been looking at solving that for cloud analytics, the Tableau users, right? The click users who are using the Tableau cache, the click cache, right? You don't see them in the database. So solving that at scale and all the different features and functions that are now eminent, we will start to talk about, of course, privacy, GDPR, CIPRA, Quebec 25, but then now we also spend some time with Ulf, which is his expertise around the quantum resilient element of our security, right? Would TLS be still secured in the next few years? And of course, right, there's those rumors that already governments are starting to record TLS communication because TLS will be broken in about 3 to 4 years, right? So how do we provide over and beyond protection in the era where nothing is secure, nothing is protected? So we'll also touch that. Yeah. So first question, Ulf, what's your perspective around around AI, cloud technologies, right? How can we really protect that at scale, protecting sensitive data? What's your take about the move to there?
Yeah. So Alon, I would like to put you on the spot here.
Sure.
Are you ready for some questions?
Always.
Okay, good. So I'd like you to answer the following questions before I dive deeper into quantum and the quantum landscape. So my first question is, as you know, we now live in the age of AI, cloud, and data. So I would say it's outpacing traditional security. That's my view. So let me ask you, why is protecting sensitive data now more critical?
Sure. Well, with the proliferation of both the data platforms in cloud, as well as the proliferation of ways to go to and see the data, right? And to use the data for more business, right? This is something that everybody wants to solve from a security perspective. And its proliferation is opening different and new ways to utilize the data and hence also expose the data to more risks, both insider risk, the fact that one department would be looking at another department information, although they didn't get a consent to do that. We see that especially around solvency laws, right? Client data of a Swiss bank is spread everywhere, and access the data can be done today even by sitting in a train and taking the train from the Geneva office to the Paris office. As you're traveling the train, you're moving from the Swiss privacy regulation to the GDPR, right? Because in Switzerland, you have the Swiss Information Act, and in France, you have the GDPR, right? So how do you impose different restrictive access when the only thing that has changed is your location? So both the proliferation of data creates a lot of challenges to protect data everywhere, and the proliferations of ways to the data, whether these are mobile devices, new applications, and of course AI that gives additional ways to interact with the data in a more intelligent way. All of these create a huge challenge to keep abreast of the regulations, to keep abreast of the consent required today when using the data, right? So all of that comes to fruition and will be just accelerated over time. So that's really my take. Yeah. What about yourself, Ulf? What do you think?
Yeah, I agree. And I would like to ask you a second question.
Sure.
Is network, application, and endpoint security approaches enough?
Yeah. So, and it's really something that I assume both of us relate a lot. Data security over the last, I would assume, right, 20 20, even 30 years, was shadowed by, right, the endpoint security, the network security, the application security, right? Even application security, right, what those guys are doing, if you look at application security, it's primarily around identifying vulnerabilities in application source code, right? And I think, right, both me and Ulf, right, we have this DNA of focusing on data, because data is affecting everything. Data is affecting the network security, it's affecting the application security and the endpoint security. Eventually, what all of those um, substantial data security domains have everything to do with data, but none of them has really taken data into consideration. If you look at your, back in the days, firewall configuration, right? Access to data was not part of the firewall configuration. If you look at the endpoint security, right? The data is not part of the endpoint configuration, as well as application. Is it a very sensitive application or not? It's not part of the application security. And of course, adding data to the mix is vital. We see that now when we look at the CNAPP, right, at the cloud native application security, right? The CNAPP and right, both Palo Alto and Wiz and those companies who are promoting this are now talking about the CSPM, and now the expansion of CSPM into data. So due to regulation, due to the fact that they've been blind for so many years, now the CSPMs, the Cloud Security Posture Management tools, are now taking data into consideration just for prioritization, right? They're not really doing active protection of encryption or masking or controlling or even monitoring access to the data. But they currently are just taking the data context and trying to prioritize the thousands of alerts that they push to the SOC team. They try to prioritize the alerts based on the sensitivity of the alert. Like if there's a bucket and in the bucket there's a database, right? Then they will prioritize this alert of patching the packet, this bucket, higher than if it's a bucket that doesn't have a database running on it, right? So we see the data now lurking into all of those pillars. Especially we see that in the CSPM play, that start to understand the place and the urgency and the criticality of data, which is now we see that in real life now, and this will just go and put the flashlight in the next few years, also taking that prioritization, currently only prioritization of alerts, into actual remediation, right? So once I detect a bucket with an RDS data store with all my client data, it's not that I will just trigger an alert to patch this access to the bucket, but now also to maybe dynamically mask access to the data, maybe to audit and monitor activities on this database, as well as maybe encrypt or tokenize the critical columns that we have identified in this bucket. Right? So that's my take. What's yours? What do you think, Ulf?
Yeah, I agree, and I would like you to dive a little bit deeper into what you think is the future of data security.
Sure.
So I would like to discuss real-world strategies to safeguard your organization. You started to talk about different methods, but let's continue with one question that I receive a lot of different answers and questions about. That is quantum resilient encryption. So my question is, can you future-proof your data at rest against quantum threats?
Sure. So of course, I'm not an expert about quantum resilient approaches. The only thing I can mention before I give you the I give you the time to talk about that It's just the fact that quantum resilient, of course, right? Our approach to quantum resilient, when we talk about it, is first and foremost not rely on the out-of-the-box encryption provided by the cloud providers. You need to do something over and beyond. And what we recommend customers is start with what we call client-side encryption, which means that you do not bring your key to the to Snowflake or Databricks or to the cloud data platforms. You hold your key, right? And you use, of course, AES 256 key length, right? It's the minimum that should suffice for at least the first years of quantum computing. So the first thing we would recommend is using a client-side encryption, and this to do on everything that you're lifting to cloud, especially in places where there's huge cloud data consolidation, like Snowflake, Databricks, Redshift, BigQuery, right? Starting there, because there's a huge consolidation of sensitive data from all over the organization lifted there. So that's my what we usually recommend customers to do. What do you think about it, Ulf?
Yes, and I frequently, I agree, and I frequently hear that randomness is very important for quantum resilience, like random tokens and so on. But I will, as you said, I will dive deeper into quantum later on in our presentation. I would like to talk to you more about the real world strategies to safeguard organizations. So my first question that I usually receive is, what is attribute-based access control?
True. So, both of us have been long enough in the industry to right, to see the transition from the standard role-based access control, right? Organizations have been building role-based access control for many years, and to this date, right? All applications, all cloud analytic platforms, right? Everything is based on roles. You log into a database, you assign a role. You log into your applications, whether this is an on-prem PeopleSoft or Salesforce, right? You assign a role, and this role authorizes you certain type of actions and access to data. And that's how the world of IT has been working for the last 20 years. What has changed is the fact that role is not the only attribute you need to take into consideration when authorizing activities, when authorizing access to data. We talked about this example of this banker moving in the train from the Geneva office to the Paris office, and here, right, the role is not enough because you need also to take into consideration the location. In other places, you need to take into consideration the citizenship, or you need to take into consideration the customer type or the customer consent. We have one of the top 10 car manufacturers of the world as a customer, and they recently had to embed into their entire cloud analytics a new attribute called consent. And consent comes in 9 different flavors. Are you allowing consent? Are you, as a car owner, you give a consent to analyze your data for technical perspectives, or maybe for marketing perspective? I might want to give a consent to my data to be used to analyze my car performance, to notify me before something needs to be done in the car. But definitely, I don't want to bring my location telemetry to this car manufacturer just to send me advertisements. Right? So now the data and the role need to be taken into a new level of considerations, and this comes from multiple types of dimensions. We talked about location, consent, clearance levels, citizenship, types, new types of, right? And this even comes to be more complicated when you have mergers and acquisitions, right? The vicissitudes of organizations that they need now to cut the access to the data in many different ways. And for that, there has been a definition called ABAC, attribute-based access control. Sometimes customers call it policy-based access control, but we decide not to call it policy-based access control because everything is based on policies. Also, the role-based is based on policies on roles, right? So that's why the way that we like to call it is attribute-based access control. It is mainly now proliferated in cloud analytic environment because more data is lifted to cloud analytic environments, Snowflake, Databricks, BigQuery, Redshift, all of those environments. And there, because there's a lot of consolidation of data, provisioning access to an analyst or to a data scientist or even to an admin, a cloud admin, needs to take multiple considerations because otherwise you just give them access to all data. And hence, this is something that comes to mind with a situation called role sprawl, right? Role sprawl is something that if you don't have ABAC, you quickly come into. Let me show you a nice slide that talks about it, that we sometimes use in order to show the role sprawl, right? The role sprawl is a situation where simply you start to have more roles than users, right? You start to have thousands of roles. And what happened then is that when you have this role sprawl, right, then you need to fix it. And this is a way that we present it, right? When you start your journey and you lift data, right, everybody's happy. It's very simple. You have just a few roles, which is, of course, too permissive, right? You allow too many users to see too much data. And that's where you start. And slowly but gradually, you add more and more roles as you need to improve security and compliance levels. You create more roles, which lowers your simplicity and hurts your scalability. And this is something that is happening to all large organizations that have their role sprawl situation. And what we, with the ABAC, with the attribute-based access control, we're able to take out this role sprawl situation and simplify the role sprawl by helping organizations to define policies that are much more generic, to take into multiple attributes into considerations, so they don't need to come and define more and more roles, more and more fine-grained, right? A role for Germany, a role for Sweden, a role for European, a role for US, right? All of those different roles can be consolidated into one policy that just takes a consideration of citizenship, location, and citizenship of the customer, right? So the ability to pull different attributes into one policy takes out the role sprawl situation, and we see that a lot in more mature Snowflake, Databricks, and of course this also is proliferated to cloud.
Yeah, I agree. And this is very important. The ABAC, or attribute-based access control, and I view it as a cornerstone for zero trust. Yeah. And we are finally getting attention around zero trust. It took more than 10 years. I started to talk about the concept of zero trust with John Kindermark when he worked at Forrester. And now we actually see organizations are starting to implement zero trust. So thank you. The next question is about monitoring for cloud. And frequently I receive questions about how can I monitor and protect cloud data platforms, critical applications, and databases in real time. So could you talk a little bit about real-time observability and maybe UBA?
Sure. So, today the approach of monitoring access to data is all done after the fact, right? I would take application logs. I would try to analyze database logs. All of that comes after the fact. Right? And we, as we are now 2024, right, we need to be much more proactive. And in order to be much more proactive, we need to be able to intercept the requests of the users, human or non-human requests, right? And apply controls on the way that those are being pushed to the different end users, right? In a way to show that, right? Right there's the different applications that need to be taken into consideration, right? And there's also the need to apply that at scale everywhere data is moving from applications, end users, right? The different types of ways to the data. And this is, of course, can be done by having this brain, as we call it, right? A management server. This is where we will be defining policies, pulling attributes. We talked about the ABAC concept, right? So we will be pulling attributes from different attribute sources, identity attribute sources such as Okta or Ping or your role or your SAP HR role. Right? And we will also be polling or data attributes, sensitivity of the data. Is it HIPAA under HIPAA or not? All of those will be mainly pushed into a server, and then the enforcement of that will be done by different ways. And here, flexibility is really important for us, and also the ability to do that with no code changes, also very, very important. Right? The zero code is critical. Long gone the days where you can just do a heart surgery on your application and call, write an API or create a view that you will need to change your report to call a view that will invoke an external function, right? Today's situations is that ITs have been so complex, both on-premise and now with all the cloud data platforms. So the no-code or the zero-code is critical. And hence, we have taken a lot of time and effort into building these zero-code enforcers that can be either transparent gateways, but true transparent gateways. You just, point your Tableau or the Beaver into a pod, and the pod takes everything, does everything for you. It will intercept the request, it will validate the user, it will validate the attributes related to the request itself, it will apply the dynamic masking, filtering, row, column, cell level, and also it will tag and classify the request to ensure that the user is not abusing his privileges, or the credentials of the user has not been stolen by a hacker. Right? So to do that in real time, and to do that at scale, to scale that through agents or through transparent gateways, or using agentless, using different options to do that at scale, to support both that from on-premise, because still a lot of applications are on-premise, and of course in all cloud workloads, right? From the Azure, GCP, AWS, from the operational to the analytical, from the AWS RDSs and Azure SQLs to the Redshift, BigQuery, Snowflake, and Databricks. So that's our approach to how to do that really at scale, and to transform from a reactive way of securing the data into a proactive way to securing the data through the lens of by pushing out those zero code enforcers that can attune to the challenge and apply that at scale. What's your take about it, Ulf?
Yeah, I think you have good points here. I would like to go back to what you said initially about data masking. So I get a lot of questions about the difference between dynamic data masking and non-production masking. Can you talk a little bit about that?
Sure. So, right, dynamic masking and physical masking, right? Dynamic masking, the name comes from the fact that you will use a dynamic masking when you access the data. The data in the databases or in the files, wherever the data lies, it's still intact. It is still in clear text. Nothing changed there. The only thing that changes is when you are polling the data into your applications, into your DirectDB tool, into your browser, the data will be masked for you. It might be that a certain user will see the data masked, dynamically masked, and another user who has privileges will see the data in clear text. Right? We will apply A back. We will apply different attributes to decide whether you should see the data dynamically masked and your peer should see the data in clear text based on the purpose, based on consent, and other attributes that we have talked before. Physical masking is going to the databases, to the data platforms, and changing the data at rest. That's physical masking. Historically, physical masking was used for non-production environments. When you were cloning your databases for developers, DevOps, for doing the development cycle from the lower environment of the development environment, or the test, or the UAT environments, you would usually use physical masking to mask the data, and you would usually use dynamic masking in production to restrict access to the data on a need-to-know basis, what is called the least privilege access to the data. Again, part of zero trust, right? The least privilege. So we use physical masking for non-production and dynamic masking for production. What happened is that sometimes physical masking is too hard to implement. For example, you're creating an environment or cloning it every day, right? You cannot physically mask a database that is terabyte of size or even petabyte of size every day, because just masking the data physically will take you a week due to the sheer volume of the data. But you're cloning that every day. Why? Because you want to provide, a reporting environment, or you want to apply a near production testing environment, right? So physically, you cannot even do the masking. In other use cases that we see, especially in large financials, healthcare, insurance, that have very complex non-production environments, it is too hard to physically mask the data because it will quickly cause corruption. Why? Because you mask, the customer name or the customer ID or the policy number in database A. You would mask 1, 2, 3, 4 to A, B, C, D, for an example. But what happened is that this data would be moved to another database. In the other database, it's still 1, 2, 3, 4. So validation will not work. Validation in the application will stop working. Why? Because there might be some validation in the application that is looking for a policy to have some type of a check num, right? A credit card. So this would fail. Sometimes when you try to physically mask a column, right, it's a primary key. You need to go from the foreign key to the primary key in order to do the masking in the right way. So there's a lot of complexities with physical masking. That's why physical masking projects take a lot of time and effort. So our approach for that is to try to do a hybrid approach also for non-production. Even for non-production, we would recommend customers that certain columns, let's physical mask them, right? For example, first name, right? There's no validation done on first name. There's no joins on first name. There's no, first name check num, right, on that. So for first name, for example, we would definitely recommend just Xing that out to do some physical masking. But for example, for policy number, for sometimes social security number, right, for values that you are massively using in your non-production environment, trying to physically mask them will easily cause corruption and testing will stop. In those cases, we would recommend you to do dynamic masking even for the testers, for the developers, for the people that are using the data in non-production environment. So the mixture of dynamic masking and physical masking, now we recommend users to use them both in non-production and in production.
That makes sense. And I think dynamic masking is becoming more and more important.
Yeah, for sure.
For live systems, and then of course non-production for your test systems and analytics and so. Yeah. I get a lot of questions about monitoring, logging, and SIEM. integration. And people are saying it can be very costly. You have the license cost, you have the space requirements. And I'm looking at real-time monitoring and auditing as a very important topic. Can you talk about this and how you advise customers to make this?
So there are basically two approaches, right? One is to just take out and turn on the native database logs, right? And the other approach is use different enforcers that will capture the request of the privileged users, right? When you want to monitor for SOX compliance, right? The focus is to identify all the privileged access to the databases, and instead of looking at, as we call as the haystack, turning on 10,000 RDS native logs and take this huge volume every day, try to parse it, try to skim it down and analyze that after the fact. We think that there's also another option to use a type of enforcers that, for example, will be proxying the request of the privileged users and hence both providing real-time monitoring to access the data, right? Because when you turn on the native database logs, it's all after the fact. Those logs are populated not in real time, and then you need to pull them out from the databases. You need to analyze them. You need to parse them. You need to process them. This, of course, takes sometimes hours and sometimes even days when you're talking about large scale of databases. So the two approaches of course, are just taking the native database logs, which there's a cost of turning on the database logs, which you pay because there's additional compute involved, and also the additional crunching, moving the database logs, parsing them, preparing them for the analysis. So that's option number one, right? Option number two is providing this approach of enforcers, either sitting on the jump servers or on the VDIs of the privileged users, or simply pointing them to a gateway pod. This allows us, instead of trying to find a needle in the haystack, and in this case, the haystack is the database native logs, just focusing on the needle, right? Because the needle, in this case, the database, the DBA or the DevOps or developer activity, we just catch them because we see them as they move, as they are being interacting with the thousands of databases. So these are the two main approaches. Of course, pros and cons in each one, and every organization would choose his path. We, of course, support both option one and option two, both turning on database logs or doing that with this enforcer approach. And you can also use a hybrid, right? You can say, look, for those databases, it's very easy for me just to turn on the native database logs. Why? Because there might be not a lot of traffic there, and there might be not a lot of sensitive data in those databases. So for those types of databases, we just turn on the native database logs and then crunch it with Occupy. And then for the critical high transactional applications, that the native database logs are just huge amount of volume. In those cases, we would recommend to use the option two by putting some type of enforcer in the way to capture those requests, crunch them, analyze them, and also being able to be proactive with dynamic masking or ABAC or even blocking the request.
Can I ask you about data mesh? Data mesh. I get a lot of questions about what is it and how can you secure it?
Sure. So the way that we see data mesh is, of course, having different cloud data platforms and being able to provide a layer that will allow analysts, data scientists, but even users to query data in a free and open way, right? Open up the siloed approach of the past when you had an Oracle database, right? And you had to log into the Oracle database with your queries, and then you will need to connect to another database to pull other type of data, right? Today, it's all being democratized, and that's the notion of data mesh. Of course, with data mesh, with the democratization of access to data, so the data mesh comes with responsibility. And that's why we see the urgency to put this type of data security layer, those enforcers we talked about, on the data mesh layer, so we can control access to any type of data platform, either cloud or on-premise, through the data mesh, but still apply the ABAC, still apply the dynamic masking, still apply the controls that are needed to comply with either internal organization requirements or comply with with the GDPR, CIPRA, privacy, and sovereignty requirements.
Okay, thank you.
Sure.
You talk about different types of data protection. There are many things to consider, and I frequently get the question about, will it take a long time to implement and to be compliant?
True. So for our customers, implementation may take a few weeks' time, up to a few months, really depending on the scope and the type of architecture that they choose. Whether they choose to use, one type of enforcer, like a centralized pods of gateways, or they look to do that with native, right? The speed of the deployment really depends from few weeks to few months. It also depends what is the type of protection required. Encryption at rest, right? The tokenization, both of us have been doing that. This, of course, is challenging. It is challenging to do encryption at rest, but encryption in use, dynamic encryption or dynamic masking or applying ABAC, as this is in motion, this is something that takes, it's much faster to deploy because you're not touching the databases, the data platforms. And to do, of course, auditing and monitoring, real-time monitoring of access to sensitive data, that's, of course, very simple and very, very quick forward. So the length of the deployment really depends on what type of function you want to apply. And from the easy to the hard, right? The easiest starts with real-time monitoring, tagging, classification, and behavior analytics. That's the easy side. Then it goes to dynamic masking, ABAC, dynamic encryption, because that's protection of data in use, which can already provide you with compliance to certain types of regulations. And then last and not least, of course, is the encryption, tokenization, masking of data at rest, because that's when you are really touching the data at rest, which takes longer. That's in a nutshell.
So sometimes we hear about a centralized solution that can provide privacy and compliance for all applications, or data in transit, data in use, and data at rest. Is it possible to have a one-stop shop for this?
Sure. And that's really the reason that we founded Secupy. It was really imminent for us from the beginning that providing a piecemeal, right, would not suffice to large organizations, because data is everywhere. Regulations are tagging on top of each other all the time, and the decision, should we use dynamic masking, or should we just monitor the data, or should we encrypt it or tokenize it? The decision of what is the remediation should not be held back by technology. The decision to use even doing encryption or dynamic masking should really be on a case-by-case basis, and this should be done on a consolidated and unified platform. You might decide one column to encrypt, the other column to dynamically mask, and the third column to monitor. And hence, you do not need to have 3 different tools for just one column to encrypt, another column to mask, and the third one to monitor, right? So you want this centralized and unified platform to be able to really cherry pick. What do you want to do, or what do you need to do today? And to take a perspective of either certain columns we want to encrypt, certain columns we want to monitor, or for certain personas, for certain identities we want to mask, for certain personas we want to encrypt. So looking at that from different perspective of data columns, perspective from identities and personas, and perspective of the regulations, the means to do that. Right? This needs to be really done in sync, and hence the approach of having one consolidated, unified, holistic platform is, we believe, the only way to do that at scale.
Yeah. So you talk initially about no code, low development efforts. So what is that about? I think you refer to no database agents, no development efforts. Can you talk more about that?
Sure. This, of course, lies to the question of implementation duration, right? And what happened is that in many cases, right, when you need to apply encryption or tokenization, you have primarily a few options. The first option is, of course, change the application to call and encrypt the decrypt function. Right? So every select request, you would need to call the developers and say, look, the select request, you now need to decrypt the payload return from the database. And when you're doing insert, update, delete, right? So the insert and update, you need to encrypt the value that you are now inserting back to the database. So you need to call those developers back from what they're doing now and ask them, hey, now you need to change the code. And every time that you're running select, decrypt. Every time that you're doing insert, update, encrypt. And what happened is that more and more, and especially when you're talking about hundreds of applications in scope to apply encryption, this of course cannot be achieved. Right? It's a huge undertaking, and that's why, in addition to this approach, which of course is valid, we also provide those enforcers, which we call them zero code enforcers. The zero code enforcers are just doing that, right? Decrypting the select, encrypting the insert and the update, but without touching the code. How do we do that? Basically, in two options. One is what we call our application agent. Think of it like just like a Datadog or AppDynamics agent, where you're putting a jar file on your application that will monitor, like a Datadog agent. I'm sure most of your organizations are using a performance monitoring tool from Datadog, AppDynamics, New Relic, right? Those tools are simply putting a jar file on the application, and the jar file is doing, for them, it is doing observability. And for us, it's doing the encrypt decrypt with no code changes. That's option number one. Option number two is to use a transparent gateway in the middle. So the transparent gateway will intercept the select, encrypt them, decrypt them, and will intercept the update and the insert and encrypt them. Right? So these are the two options that we provide our customers for them to do this zero code encryption, encryption or tokenization project at scale. So they do not need now to roll back their developers and change the code of their application to do that. And we've done it just recently for a major bank, and they are rolling applications with encryption. They are rolling, every application takes them about 2 or 3 weeks time. And of course, this will also shorten as there's also the learning curve that will help. And it will be shortened even to a few days per application, where we take an application, we put in the no code, the zero code enforcer, we do the encryption, and the zero code enforcer takes care of the select, insert, update request, fully transparent, while also adding monitoring and dynamic masking into the mix. These are just other types of enforcer that the agent is providing. So that's for the zero code enforcer, and really a super powerful technology that allows large scale onboarding of encryption tokenization, which of course is mandated for PCI, for HIPAA compliance, right? And encryption and of course for quantum resilient, very, very important. And maybe before we finish, Ulf, I'm sure everybody is waiting to get some more context about quantum resilience. So what's your take about quantum resilient? If you can, share your thoughts about how to be resilient in the years to come.
So thank you. I get a lot of questions about quantum computing attacks. How serious are they? How will it be a threat to different systems? And when can this happen? So I talked to Gartner about the quantum attacks. And they basically said that over the years, quantum developed, like IBM in 2018 had quantum processors. In 2006, D-Wave and MIT University had similar capabilities. And it actually started with IBM and MIT around year 2000 to have these capabilities. So people ask me, what is practical? When will it happen? How should I plan for it? So let's talk first about what are Gartner seeing as the evolution here. They talk about post-quantum cryptography. That is different type of algorithms like lattice-based algorithms and more, coming out from a NIST competition where they actually had proposals evaluated. And those, Gartner is saying that in around 2024, we will start to see post-quantum cryptography, and we can see where we would like to apply it. And it's mainly for PKI, asymmetric. They are proposing that maybe a year after, it will be meaningful for businesses to use these algorithms. And of course, what you actually can use today are fully random or highly random tokenization for data protection. And as you probably know, fully random cannot be broken. Why? Because it's random. There's no way to break randomness if it's a high level of randomness. And of course, you always need to protect your keys, and your key management is very important. That is a kind of foundation for tokenization, encryption, and so on. And Gartner is now saying in 2028, the RSA algorithm and the ECC algorithm, elliptic curve cryptography, are no longer used for PKI. Meaning what? It means that everything that is based on PKI, like the internet, like blockchain, need to be replaced. So Gartner is saying in 2028, you need to be ready to replace internet, encryption, TCP/IP, SSL, maybe earlier, TSS, and other PKI-based crypto. And Gartner is saying that maybe a couple of years later, 2029, 2030, the RSA algorithm will be cracked. So everything that's protected by the RSA algorithm, like most of your internet traffic, can be cracked in 2029, 2030. So that's the attack scenario. I talk about customers and about data roadmaps for different issues. We talked about data security, zero trust, data provenance, quantum resilient, algorithms, quantum resilient algorithms, smart contracts that you see in different types of implementations, many based on blockchain, and then quantum processing. Basically, the benefits of quantum processing, how you can make your business applications better with quantum processing. So some of these customers are saying that over the years, they are rolling out these different capabilities with starting with data protection that they actually can do now. They can use industry standard or, well, bulletproof, different types of implementations that are proven. They want to go deeper into zero trust. And when they talk about zero trust, they talk about implementing conditional access for all, multi-factor authentication, of course. And they talk about, of course, the zero trust network and appliance, or zero trust as replacing legacy VPNs. I think that's a very important statement they make. And they also say encrypt all data in transit and rest in cloud, and control your keys. Make sure your encryption keys are not distributed into, can protect against different attacks. And it's of course a balance, but never give away your encryption keys. That's what they basically say. These customers also say to implement zero trust, they want to remove admin rights from most users. And we know containers, they are in too many cases running with admin rights for no reason. It's kind of a lazy approach. And when someone breaks into your container and it's running with admin rights, they have the keys to the And finally, they typically tell me different networks, microsegmentation, so you are not running a flat network. They talk about ring defense or ring fences for critical applications. Only critical applications where you have, for example, credit card data, and so. I think, Alon, we are running out of time. Yes. So do you have a final statement that you want to make?
Focus on data, right? Use all the colors of the rainbow that best suits your requirement. We talked about many different options to protect data, and we'd like to have to continue the discussion with each one of you. Ulf, any last remark from your side?
Yeah, I think we covered many critical topics here, and I view the trend in security is to protect your data, lock down your data, and it's not enough to protect your networks and endpoints. and applications. Lock down your data.
Thank you very much, Ulf. It was a pleasure doing this with you. Thanks a lot. Thank you for all of you joining us, and have a great remaining day. Thanks a lot.
Thank you
Bye-bye.
very much.
Thanks, Ulf.